What is a neutron star? A neutron star is the remnants of a star 4 to 8 times the mass of our Sun. They are incredibly dense, around 1.4 times the mass of our Sun, shoved into a sphere the size of Manhattan. They rotate very fast and can reach speeds of 43,000 rotations per minute. Their magnetic field is also extremely powerful, at 1,000,000,000,000 times that of the Earth. Finally, they also have the strongest gravitational pull in the universe out of anything not named black holes. In fact, the gravity of a neutron star is so powerful that it can bend light, and if you were to look at it, you'd see these weird shimmering effects because light was being bent. If something were to get too close to a neutron star, it would pull it towards it at around a half the speed of light, and that thing would be ripped to atoms before it could even reach the surface. Now that we have a general idea about what a neutron star is, let's look at how they're formed. Stars are in a constant battle between gravity crushing inwards and fusion fighting outwards. Massive stars fuse hydrogen into helium, helium into carbon, carbon to nitrogen, and eventually silicon into iron. Iron can't be fused. Without anything to fuse, gravity wins and the star collapses in on itself. The core is shrunk from about the size of an Earth to a 20-kilometer wide ball. All the electrons are forced into the nucleus and collide with the protons. This forms neutrons. Eventually, the core has barely any electrons or protons and just a lot of neutrons and becomes a neutron star. The rest of the layers of the star bounce off this neutron star in a supernova. Let's talk about the parts of a neutron star. Starting at the top, let's discuss the atmosphere. It's extremely dense, but just about 4 inches tall because of all the gases pulled so close to the star's surface because of its immense gravity. The crust is made of ionized iron, electrons, and superfluid neutrons. Underneath the crust, neutrons are packed together in pasta shapes, which is known as nuclear pasta. The outer core is also believed to be made of superfluid, which is a fluid that moves without losing any energy. However, the contents of the inner core is still unknown. All of this contributes to the incredible density of a neutron star. In fact, a cubic centimeter of neutron star has more mass than all the humans on the planet of Earth that are alive right now. Let's check out a couple types of neutron stars, starting with magnetars. As the name implies, they are very magnetic enough to have the strongest magnetic field in the universe at 1,000 trillion times that of the Earth's. They also can dissolve anything within a 1,000-kilometer radius due to their immense gravity and radiation. Unfortunately, they live for just about 10,000 years because their huge magnetic field accelerates nearby matter, which acts as a drag, causing it to become weaker. Now on to pulsars. These neutron stars spit out beams of radiation. This is caused by their magnetic field and electrical field creating massive amounts of radiation, which is spit out from the poles. It's spit out from the poles because that's where the magnetic field comes from the star. The pulses are like clockwork and are consistent and unique to each pulsar. Scientists have discovered about 2,000 pulsars as of today. Neutron stars don't just come solo but also in pairs. These binary stars will spin around each other and eventually collide. The collision of two neutron stars is called a kilonova. The first one was observed in 2017. When two neutron stars collide, they create a black hole. These collisions also create heavy elements like gold, uranium, platinum, and more. These elements can make their way into solar nebulas. When the nebula becomes a solar system, the elements fall onto the planets. Many of the heavy elements from our own Earth come from the destruction of two neutron stars. I hope that you learned something new watching this video, and thanks for watching.